So first of all, welcome, Torty Gallus. I appreciate your time today, coming together to listen to an AIA presentation. Just a quick introduction to myself. My name is Nicole Dyer, and I joined Allegion 2 years ago. Started in the architectural support role at the end of March as John Kraus retired. So I've been in the industry 25 plus years, most of it in distribution as a project manager, and I'm absolutely thrilled to be on the Allegion team. And joining us today is Rick Bale. He's a colleague of mine who's an architectural rep in the Philly area and north. So we're happy to have him with us also. If you have any questions, feel free to speak out. Some of those slides are going to request some interaction from you. So if you can give me some feedback, that's awesome. And we'll also have a little bit of time at the end. I do ask if you need an AIA certificate for attendance today. First of all, we need you to stay on the entire call. And also, if you can provide me with your AIA number, that would be awesome. Okay, so off we go. Okay, so again, this one, the course that Danny and I selected today is specifying door hardware, which is all about the different components of hardware and the code's situational factors that affect which products to specify for a particular opening. These go through the objectives. This information was on your invitation also, so we're just going to dive right in. So everybody loves door hardware, right? That's specifying that piece of the project is your favorite part. So where do you start, right? Here we go. So I suspect that everyone recognizes that door hardware is a complicated business. And years ago, somebody called me up from a contractor's office and said, yeah, I need a door frame and some hardware. And I said, what kind of hardware do you need? Oh, you know, just the standard stuff, which is really no such thing. So these are just a sample of the different conditions and circumstances that affect hardware. And it really doesn't mean to be, it's not designed to intimidate you. It's just to give you some idea of all the things that are going on while we're looking for hardware. So location and conditions is about, you know, is it interior, exterior, affected by weather or not, frequency and type of use. You're going to need different kinds of hinges for a closet door in someone's office versus the front door on a school, for instance. The owner's needs and wants, which can be challenging, right, for us to determine what they need, what they want, and try to come up with a plan that best suits those desires of theirs. Door and frame material, again, you can need different closer installation components for an aluminum door versus a hollow metal door, wood frame, hollow metal frame, aluminum frame, that sort of thing. Those things can affect fasteners also, machine screws versus wood screws. Door thickness and weight, you know, standard commercial doors are 1 3/4 thick. Some residential are 1 3/8. Some are thicker than that. Again, regarding a hinge, for instance, a heavy door requires a different hinge gauge thickness than a lighter door. So, door backset. This is a term that refers to the dimension from the lock edge of the door to the center line of the lock set. We'll also see later on a reference to a hinge backset. Clearance requirements, you know, how much for a particular type of door. A double acting door could require different clearances than a single swing door. Clearance requirements are affected by fire ratings for undercut, that sort of thing. Mechanical or electronic security. You know, if this door needs to lock, how are we going to do it? One of these or both of these. Climate can be not just the interior, exterior, but changes in temperature or humidity. Corrosive climates like pool areas or seaside locations because of salt. Accessibility. You know, is this an opening that needs to be accessible by someone in a wheelchair or someone that needs additional time going through an opening? It can affect the width of the opening, the threshold dimension, a number of different factors. So this can be a circle of joy and a circle of pain, but again, this is why you've got hardware consultants to assist you and help you navigate through this this process. So it's all good. It's all good. So in addition to some of those factors we just talked about, codes affect what happens with the hardware as well. Positive pressure is a reference to how fire-rated openings behave in a positive pressure situation. Life safety is one I think we're very familiar with paths of egress and limitations to what you can do through those paths of egress. Accessibility again, and then fire-rated doors and windows. And the cool part is there are times when all four of these are happening at one time, but no worries, it can be done. These are some of the covers of different code books that relate to fire doors. NFPA 80 is about the installation and maintenance of those openings. For instance, you'll see that undercut information in NFPA 80. UL10C is a reference to labeled doors. This is an example of a fire door label. And there are a couple of things I want you to notice about this. First of all, it says door. There is a different label for frames. It tells you who the labeling agency is. This one is UL, could be Warnock Hersey or another labeling agency. This tells you what the time is, what the limitation of this fire label is. This could be 20 minutes, 45 minutes, whatever. This also refers to temperature rise, an additional designation. And this line is critical as well. This says fire door to be equipped with fire exit hardware. Fire door labels will have specific description of what the latching hardware is, either fire exit hardware or latching hardware, meaning a cylindrical lock or a mortise lock. So if an inspector were to see this label on a door with a cylindrical lock on it, he's going to flag it because it conflicts. So it's good to know what those labels look like and what the different pieces of information mean, how they affect the opening. And this is a reminder of why it's so important for these labels not to be disfigured or painted over during construction or afterwards. NFPA 101 is about the life safety code, and there are a number of key points. One operation egress means that, for instance, as you approach a panic device on the way out of a building through a path of egress, it's one motion, right? You just depress the rail on the exit device and leave. If it's an opening with a interconnected lock, lever down below and a deadbolt up above, and both of them are latched, if you depress the lever, it retracts both the latch bolt on the lever and the deadbolt. So that's what one operation egress is in reference to. It also discusses access controlled egress doors and what the requirements are there. Delayed egress is a situation where, for instance, in a memory care unit, possibly in a retail location for security, an opening will have an exit device that has a special function feature to it so that you can depress the rail. It doesn't release immediately. It generates an alarm and typically a signal to an access control system after a delay, typically of 15 seconds. Egress is allowed, but the whole idea is that it's controlling that path of egress, so somebody knows what's happening when someone leaves there. It's not a standard path of egress. Stair reentry is a reference to the requirement on some multi-story buildings with secured stairwells, so that in the event of an emergency, someone who is in the stairwell will be able to re-enter one of the floors, because much as we look to stairwells as a safe place and a way to quickly exit a building, there are circumstances where the danger is actually in the stairwell and you need to get from the stairwell back onto a floor. So that's what stair re-entry is about. And door closers with 5 pounds to open. This is a reference to how easy it is to open a door with a door closer on it. And just to clarify, this reference is to an interior non-rated opening. Okay. Next slide is about the ADA accessibility standard and the different pieces of information that are typically applicable and most common, the things that we see most often. So levers have become the standard for door hardware. It used to be knobs in some older facilities, some government buildings, you'll still see knobs, but levers are the accessibility standard at this point. The idea there is that there's no gripping or twisting motion required to operate that piece of hardware. Closers, again, the maximum opening force of 5 pounds, interior non-rated doors. And this comment, minimum close time from 70 degrees of opening to 3 inches from latching is 3 seconds. That prevents a door from, doesn't prevent, it's so that a door is not adjusted, closer is not adjusted so that it slams, right? Because you're working your way through the opening. The last thing you want is for it to all of a sudden get to that closing area and then quickly close on you. So that's what that's all about. Threshold height, I think this is one that people are very familiar with now. 1/2 inch maximum total in 1/4 inch increments. And when that needs to be accomplished over a greater change in height, for instance, maybe as you approach the opening it's 1 inch lower than the level of the door opening, you would need to extend the total width of that threshold in order to maintain this 1/4 inch increment height change. Minimum door width of 32 inches clear, max 48 inches, and a minimum of 80 inches high. And then the bottom 10 inches of the door must be smooth, and that is to allow people to, as in the gentleman approaching the doorway here, he's got the foot holders at the bottom of his wheelchair. You don't want those to snag on anything at the bottom of the door, like a full height pole, some other sort of guard or protection down there. So this is all good stuff. So this slide, tried and true versus new technology, is to help us think about and evaluate hardware from the perspective of tried and true hardware, which has been around for years and years and years. I think we all know that hinges, for instance, have been around forever, but there have been evolutions and innovations in design that have made them, in some cases, a better application. For instance, a swing clear hinge, one of the hinges that's designed to prevent pinching of fingers for childcare or educational applications. So there are all kinds of things that are going on, but you need to look at them and see, you know, is the innovation appropriate? Do I need that or not? So all things to consider. So what we're going to do now is go through the different components of hardware in the DHI or Door Hardware Institute format that we use for setting up a hardware schedule. We start with hanging the door, then move to securing the door, controlling the door, and protecting the door. So best place to start is to hang the door, because if we don't get it swinging in the opening, we don't have much to go on. So this is a slide I'm not going to belabor, but this is a reference back to the concept of having the right hinge or the right piece of hardware for the application in reference to cycles and how often is this opening going to be used. So possibly this grade 3 hinge, standard weight without bearings, designed for 350,000 cycles, which by itself sounds like a lot, right? But this is the kind of hinge you may put on that closet door, as opposed to this grade 1 hinge. This is the kind of hinge that you would put on the front door of a school. So this isn't anything that you need to memorize. It's just an idea or a way for you to recognize how different hinges may be used and why you may see different grades of hinges or weights of hinges on the same project from one opening to another. So it may look inconsistent, but it's actually driven by this sort of thing of which cycles, what the openings are going to be used for, and which hinge is the right hinge for the job. These are additional details that you'll see for hinges, other things that we consider. Door thickness is here. This is the hinge back set. You'll notice on handed doors there's the mortise pocket that's made for the hinge leaves a small amount of material on the edge of the door rather than mortising all the way through. This back set is that dimension. Hinge types. Here we go. This is the conventional hinge, which is a standard, also referred to as a butt hinge. This particular hinge has bearings. That's what these items right here are. And this is a swing clear hinge. These bent flanges allow the door to swing out of the opening. You'll see these sometimes in healthcare applications as a way to maximize clear width for moving either wheelchairs or stretchers or that sort of thing through openings. Great application hinge. Continuous hinges, you may hear these referred to as Roton hinges, which is actually a manufacturer, but one of the early ones. Also as a piano hinge, the type of hinge that's used to connect the cover of a piano to the rest of the body of the piano. These are used in high traffic applications. They're also used in some retrofit applications. Pivots, this is one of my favorite pieces of hardware. I love this piece of hardware. These are a great swinging device in that all of the weight of the door sits on the bottom pivot. This is a bottom pivot. This pin sits in this recessed opening. There's a bearing in there. The full weight of the door is on that bottom pivot. This is the top pivot, and this is an intermediate pivot. So these two are designed to keep the door vertical in the opening, but again, all the weight is on the bottom pivot. These are used with heavy doors like lead line doors. You'll see pivots used on some storefront openings, glass doors, that sort of thing. Any questions on hinging before I move on? Okie doke. Securing the door. So this isn't just about literally locking the door, it's about latching the door. Common lock types are cylindrical or board locks. These take a 2 1/8 inch circular hole in the face of the door. Deadbolt, this is a lever set, obviously. This is a deadbolt, which would be installed above. Mortise lock is a reference to this large lock case, which is mortised or drilled, pocketed out into the edge of the door. This is a cylinder. Good news with a cylindrical lock, typically they're unhanded. You can swap function from this keyed function to a passage function without having to concern yourself with the prep on the door, as opposed to a mortise lock, which is prepped according to function. There's always this pocket to support the mortise lock body itself, but the lever and or key can change by hand and by function. So you need to be very careful about which function is specified for a mortise lock application. Question here, how many different lock functions are there? Does anybody have any idea? Seems like a million, right? Actually, 50 is the answer, greater than 50 of them. And the good news is these are the standard functions that we'll typically see day in and day out. Passage is no key. It's a free egress at all times and free access from the exterior. Privacy is the function that has a push button on the inside, but no key on the outside. Office is push button on the inside, cylinder on the outside, the key. Classroom lock, which is something of a misnomer because it's used in different sorts of applications, like some conference rooms and other areas like that, has a key on the outside, no push button on the inside, and the cylinder locks or unlocks the lever, exterior lever, until the key is used again. So for instance, a classroom would be locked overnight, and when the teacher comes in the morning, she would unlock with the key, and it stays unlocked during the day. This one you have to be make sure that people understand operationally it will not relock behind them, so they need to be aware of the process to relock it. Classroom security became a common function after there were some tragic incidents at schools, and the idea with this classroom security lock is, as I said before, for a standard classroom lock, you need to be on the outside of the opening to relock this door. Classroom security function allows you to lock the exterior lever from the inside, which keeps people on the safe side of an opening should there be some sort of concern in the hallway. Storeroom lock is a key on the outside. The exterior lever is always rigid, and you need the key to retract the latch. This is a common function on mechanical rooms, electrical rooms, janitor closets, and that sort of thing. This one is commonly used with a closer because if the door isn't self-closing, it's possible to leave it open, which means it's unlocked, right? Another thing to note is that for all of these functions, there is always free egress from the inside. The function is driven most by what happens from the secure side of an opening. Lever handle designs have become more and more prolific over the past 20, 30 years, which is a great thing from a design perspective. There are some limitations about functions based on the lever, but anyway, there are many, many more design options and finish options than there were. Just a note about this comment down below here, California has a lever that has to return within a ½ inch of the face of the door. And the idea is that for emergency personnel traveling through buildings, for instance, a fireman running up a staircase, he's not going to have to worry about snagging his equipment on his or her equipment on a lever like this, which sticks out from the door that can catch a hose or a backpack or an oxygen tank strap, something like that. That's what drove this California code. Exit devices. So exit devices, sometimes you'll hear them referred to as panic devices. This is a surface vertical rod, top rod only, no bottom rod. This happens to be a double egress opening. You can see that the doors are swinging in opposite directions. This reference right here is about the length of the push pad, which is the moving portion of the panic device. This needs to be a minimum half the width of the door. So for instance, if this was a 48-inch door and this panic device didn't extend far enough so that this actuator bar was of sufficient length, it's a violation. And the whole idea again is if you're coming down a hallway and let's say the lights are out, power is out, or there's smoke, you don't want to be fumbling along the width of the door to find the piece that gets you out. And although that would be different with a lever set, panic devices have their own sets of, they're used in specific applications for a reason, and that's one of them. This slide is about panic hardware versus fire exit hardware. So exit devices, panic devices are used on openings that are not fire rated. For instance, an exterior door, they're commonly used on egress doors out of a building. So they provide free egress. Dogging is permitted on panic hardware, which means that you can depress the rail and keep it depressed on panic hardware, and you can mechanically dog it or electronically dog it. UL panic hardware label is not to be confused with a UL fire label. The panic hardware label means that it's been tested and will function as necessary for egress. Fire exit hardware is panic exit hardware for use on a fire door specifically. In that case, mechanical dogging is not permitted. Just a reminder of what the requirements for fire door hardware is. It needs to be self-closing and positive latching. If a latch bolt was mechanically dogged, it would be unable to positively latch into its strike, which makes that a violation. So that's the reason why you can use electronic dogging on a fire door as long as it's connected to the fire alarm. So in the case of loss of power or a signal from the fire alarm, that latch bolt will extend and allow it to positively latch. Must have a UL fire exit device label. That label is going to be on the case of the device, and again, must be self-latching. I'm not going to linger on this slide. This is similar to the hinge slide regarding cycles and which device is appropriate for an opening with high frequency versus medium frequency. Specifying the right exit device, there are different models and styles. Low profile device is this device that's actually mortised into the face of the door. So the part that protrudes or projects from the face of the door is the actuator bar. This is a device that can be used on a metal door only, because if you were to mortise that amount of material from a wood door, it would challenge it structurally, which is not a good thing. So this is a low profile device. Architectural finishes, they're available in polished brass, satin chrome, satin stainless steel, oil rubbed bronze, all sorts of different finishes, architectural devices. Lever designs can match the balance of the project. So in addition to the fact that there are many more lever styles than there once were, there is also a focus on suiting the lever styles so that you can use the same lever style from your exit device trim to a cylindrical lock to a mortise lock. Ways that functional hardware, can now contribute to the aesthetics and the design feel and atmosphere of a building, which is a great thing. This is delayed egress again. It's a panic device that's designed to prevent immediate access for either safety or security reasons. Again, common in memory care applications or retail rear doors, that sort of thing. When the device actuator bar is depressed and held, it will, after 3 seconds, initiate the irreversible process, which allows egress in not more than 15 seconds. So that irreversible process and that delay from just bumping the device to holding it down for 3 seconds, that means if somebody just accidentally bumps into this, it's not going to go through that irreversible alarm state process. And you'll see there's a cylinder on this rail for this device. These, once they're actuated, need to be reset. And the idea with the key is that it's someone that's responsible that has that particular credential, in this case, which is a mechanical key. This slide is in reference to opening hardware design, period. And it's not just about mechanical hardware, it's also about electrified hardware. How should this opening work? It's especially critical with electrified hardware so that everybody understands what happens when you approach the opening, when you present a credential. How does the hardware behave? Is the opening monitored? What happens with the access control system? All of that sort of activity. So it's really important that conversations are held early and often about opening operation so that the right hardware is specified and the coordination occurs between the owner, the architect, the subcontractors, and the security integrators. And mechanical hardware can be spooky enough. When you get into access control and electrified hardware, it can become even more challenging and more complex. Again, that's a situation where leaning on your hardware consultant will make it much, much easier to navigate and help structure those conversations so they're productive. I'm not going to linger on this slide either. This is about finished hardware and the different types of applications that you'll see, different types of hardware for a particular application. Some of this is related to convenience, some is related to how the doors have been tested, especially fire doors with latching and that sort of thing. You'll find that there is frequently more than one way to achieve the functional and code requirement needs of a particular opening. Exterior applications, these are similar descriptions of the different ways that you can secure an opening. These are flush bolts and surface bolts, which are used on inactive leaves of a pair. So the active leaf is going to have your latching hardware, and the inactive leaf, which needs to be secured, is going to have some sort of latching bolt. Either this is a surface bolt, flush bolt, call that because it's mortised into the face of the door, right? All you're going to see is this faceplate and the tip of the bolt. And then you get into automatic and constant latching bolts, which are driven by need and code. These are just three of the most basic questions about starting a conversation about electronic access control. You know, when you have a mechanical key that's used for security on a facility or a particular opening, it's all about the key, right? Like what key operates what cylinder. A key isn't about who has the key. You can, you know, I can take my key, give it to Rick, and if it works the opening, nobody knows when somebody got through the opening. Nobody knows who had the key. All we know is that somebody had a key to get in. The idea of electronic access control is that you have more data about what's happening at the opening. So it's who's got the credential, whatever credential was assigned to a particular person, where did they go with it, and when were they there. Getting electricity from the frame to the door. So anytime you're talking about electrified hardware that is not battery operated, then you need to get live power from the frame to the door to power the hardware. These are three components that help that happen. This is just the cabling, the wire that's used to power electrified hardware and to get data or signaling back and forth. This is an EPT, or electric power transfer. This is mortised into the frame and into the door. And this is a door loop, which is a surface applied. One end of this goes on the door, one end goes on the frame, and the wire travels between it. This is typically an application you'll see on retrofit applications where it's not possible to conceal the wiring, maybe a stone wall with a particular type of door that can't be mortised. It's an aftermarket application. We try to avoid these because they're surface mounted, which makes them prone to vandalism or damage. Concealed wire transfer is much safer, much more secure, and wears better. This little bonus point down below here is how many conductors and what gauge. So this wire that's shown here has a plastic shield over it, and inside there are multiple strands. And for instance, 18 gauge 4-conductor wire is one. So if you ever hear something about conductors in gauge in reference to electrified hardware, it's how many strands does that particular piece of hardware require to transfer power and data. This is an electrified pivot. Again, that's concealed. Same thing with this butt hinge. The wires actually go through the flanges, through the center barrel, and back out the other side. These ferrules on the back are can be prone to damage, so that EBT that we showed on the previous page is actually the safest and least likely to become damaged. These are some system components that you'll see in an access control system. This is a power supply, low voltage power supply. 110 voltage comes in and it sends out 12 or 24 voltage to the hardware. It has boards inside that can control particular types of hardware, help send signals to the access control system. You also see an open space down here, which could be used for batteries when a power supply has battery backup. These are some pieces of electrified hardware. This particular one has a keypad, pin number capability, and a mag stripe, less and less of which mag stripes are used in electrified hardware. These are readers. This one is a card reader. This one again is keypad. This is a biometric. So all different types of hardware and components are necessary for a complete system. This is a break down the structure for the operational description of an opening with access control and electrified hardware. Credential is presented, what happens, and then how the opening is affected. Another thing, great benefit of having an access control system is this audit trail. Again, with the mechanical key, we don't know who was there and when they were there. With the access control system, we know who was there, where they were, when they were there, and we can pull that audit trail, which varies in capacity depending on the type of hardware and the kind of access control system, but that can be a critical piece of helping to maintain security in a facility. These again are some additional pieces of electrified hardware. This one shows how some hardware components have interchangeable reader heads. Could go from a keypad to a card reader, that sort of thing. Any questions about securing the door before we move on? All good. All right. Next, we're going to control the door, and this is what closers are all about. So this is just a quick poll. What can go wrong if a closer isn't installed correctly? The frame and jamb header reinforcement place welds can be damaged. Hinge screws can fail. Locks don't meet the strike properly. Knobs and levers can be damaged from force. Latch bolts can be damaged. Closer can be damaged. And walls can be damaged. Any idea which of these can go wrong if a closer isn't installed correctly? Rick, what do you think?
Absolutely.
Absolutely everything can go wrong, right?
Yep. Every time the door slams, the screws want to loosen and affect all the door. So we absolutely control the door.
Exactly. Yeah. So again, specifying the right closer is a critical piece to start with. But after you specify the right closer, we need to make sure that it's installed correctly and maintained. Closers are one of those pieces of hardware that need to be adjusted on a regular basis. And you'll find that in specifications in the execution side and follow-up side about maintaining those pieces of hardware so they function correctly, from when they're initially installed to when the building is handed over to the owner, and then a certain period of time after the fact. These are different pieces of closer construction and engineering to look for. Not going to linger there, but there are different things that can affect how a closer functions and lasts. Closer style, typically covers are one of the things that people notice most often. This one has a full cover. Slim cover would only be about half this height, and no cover, again, the closer is still going to function. It's just not going to be as aesthetically pleasing. Architectural plated finishes are available. Typically, closers are powder coated, and but you can have them plated. I will caution you that while they look gorgeous, they are expensive and they extend lead times. The good news is you don't have to plate an entire closer. And again, this is something you may want to do on a high profile opening, but not at a back of house opening. This is all about overhead closer installation methods. So parallel arm goes on the push side of an opening. Standard or regular arm are installed on the pull side of the opening. And in both cases here, the closer body itself is installed on the door. Track arm is an application like this one, where the foot of the arm travels through a track in the face of the door, similar to what a surface overhead stop looks like. It's not the same function, but that'll give you an idea what it looks like. For a top jam application, the closer is mounted above the opening on the frame rather than on the door. And a concealed track closer is where none of this is visible. You may see a small mortise in the face of the door to allow the arm to move, but basically the hardware, the closer, is concealed. What does the closer do for you? It controls the opening force and speed, and it controls the closing speed and latching force. So again, adjustment is critical on closers. You need to make sure that each part of their opening area is the right speed to make the doors open, close, and latch properly. This is a slide, brief slide about auto operators. The easiest way to think of them is a high energy operator is an operator that always opens or closes a door. For instance, when you approach a grocery store or another kind of retail store, some high traffic office buildings, hospitals, that sort of thing, just approaching the opening opens the door with one of these high speed operators. There's no knowing act, right? You just go up to it and it opens the door. These are designed to lots of cycles, heavy duty operator. These require mats and rails and safety sensors to make sure that nobody is hurt going through these openings, that traffic is controlled. A low energy operator is used for accessible entrances or some application where occasionally assistance is needed to open the door. And these are operators that initiate when you either push an actuator on the wall, or, as is becoming more and more popular with the advent of COVID, those touchless, hands-free actuators. Alrighty, and now we're down to protecting the door, and this is a an assortment of pieces of hardware that help keep the door from being damaged or keeping the opening protected. For instance, this is self-adhesive gasketing, which is used to prevent the transfer of air or sound or smoke. This is an automatic door bottom, helps seal the bottom of the opening, the gap between the bottom of the door and the floor. This is a rod guard for an exit device. This is a kick plate with a special all I can think of is stick out. I mean, obviously that's what's happening there. I'm sorry, I've lost the word for it. But it comes off the face of the door in a way that protects the bottom case of the exit device. And I think everybody knows now this kind of application with an exit device is less prevalent now with the less bottom rod devices. Again, kick plates and armor plates fall into this category. Wall stops, floor stops, overhead stops, astragals, which is a piece of hardware that would either be surface applied or mortised or self-adhesive between two leaves of a pair, thresholds, and again, smoke seal or gasketing. So in these brief few moments, we've gone through hanging the door and securing the door, controlling the door, and protecting the door. And there are additional resources that are available to you. I'm going to forward these to Danny, and thank you to Danny Ching for helping to host and get this together for us. There are all sorts of things available on our website, videos and documents. We have apps that go on Android or smartphones. Anybody have any questions about anything in particular? We can talk about something now. You can follow up with me after the event, whatever. Anybody have anything? Okay, so my final request of you is, again, as you're signing out, if you haven't yet provided an AIA number for a certificate, I would appreciate that. Everybody's going to get a certificate for attendance today, but in order to do the AIA credit, I will need your AIA number. Thank you again to everybody. Allegion places great value on our relationship with Tortigalis. You're great partners, and we look forward to continuing to do great things with you. And I really hope I can get back on the roads shortly so I can get out to visit. So thank you again. If there isn't anything else, you're all excused to get back to designing something gorgeous. So thank you, everybody.
Thank you.
Thank you, Nicole.
You're welcome. You're welcome.
Thanks.
You're welcome.
Thank you.
Sure thing.